So here we are back in Houdini, and what I would like to do is to start assembling the final scene and use a specific camera, some terrain geometry, just to lay the ground for the environment that you saw on the preview of this tutorial. So as I mentioned, you will have the terrain geometry. This was created with a few height fields. So you can take a look at this node if you want to learn how this was done. I also have a camera, the one that I used for my final render, and a distant light with a very horizontal angle just to better see the waves and the geometry that we are creating with the ocean spectrum. And just to have an idea of the length of this shot, let's go into the terrain geometry. Let's click on the information flag for this node. And you will notice how the size of this terrain is almost 200 meters square. So this is going to be something to consider for our final ocean. Okay, so I will go back to the object context and create a new geometry node. I will turn off the terrain for now. And let's change the name of this new node to Ocean Surface. Maybe we can also change its color. Okay, so let's dive into this node. And let's find the Ocean Spectrum tool. So type the Tab key and start typing Ocean. And here you will find the Ocean Spectrum. Now let's lay down this node. And you will notice in the viewport how we're unable to see anything. And if you remember, I did mention that usually this tool is used in conjunction with the Ocean Evaluate and some other geometry to displace. So first of all, let's create the Ocean Evaluate. And notice how this node has two inputs. The first input will expect geometry to the form, and the second input will expect the ocean spectrum. So let's create a grid. This grid will usually have to be very highly tessellated. So let's make sure that it has at least 1000 rows and 1000 columns. So this is the geometry that will actually be displaced. Okay, so let's connect the grid to the first input of the Ocean Evaluate and the ocean spectrum to the second input. And click on the Ocean Evaluate. So notice how now we have something happening here. Actually, if you press play, you will notice that we have some waves moving from left to right. Okay, so I'll press stop. So although we will be focusing on the ocean spectrum parameters, you will need this grid. Okay, so let's go through some of the most important parameters of the ocean spectrum. First of all, remember I mentioned that the ocean spectrum will create 2D volumes representing certain aspects of the waves: phase, frequency, and amplitude. There will also be another volume called mask that is optional, but if you want to check this information, click on the information flag for the ocean spectrum, and here you will see these volumes enumerated. Currently, these volumes have around 16,000 voxels. So back to the resolution exponent property, the higher this exponent is, or the higher this value is, the more detail you will have in these volumes. So notice how if I go down to 6, the volumes will be extremely coarse, and although my grid is very highly tessellated, I will zoom in. The volumes here on the ocean spectrum don't have enough information to represent a detailed ocean. So usually what I like to do is I start with a resolution of 9, change all my parameters until I'm happy with the result, and then I can increase this resolution when I'm about to render or to generate my displacement maps. So for now, let's go with 9. Now the grid size is the size in meters of these volumes. And here we have something very important that I want to show. I will try increasing the size of this grid to 50 by 50 meters to match the size of my ocean spectrum. I will zoom out. But notice how if I increase this value, for example, 200 by 200, you may notice that the ocean will start to tile, almost like a tiling texture. Now, there are several ways to avoid this tiling. One, of course, would be to increase the grid size. For example, let's increase this to 200. And of course, now we won't have any tiling. But if you're creating a huge ocean, it will eventually become impractical to increase the grid size because the volume will start being of a very high resolution. So later on in this chapter, I will show you a few ways to avoid this tiling. For now, I will stay with 100 meters for the grid size, and I will channel reference this value to the grid size. So I will paste that value as a reference, both in X and Y. Okay, so back to my ocean spectrum. You could, of course, offset the position of this grid, but for now I will leave it at 0. Then we have a depth value. This value represents the depth of the actual ocean. And the effect of this value is difficult to see if you're not animating your ocean, but basically you will have more contrast in speed between the high frequency waves and the low frequency waves. So if I press play here, you will notice that we have some large waves, for example here, and then smaller waves riding on top of those larger waves. So the larger the depth, the larger contrast in speeds you will have between these small and large waves. Again, this is difficult to see if we don't have a render scene, but what I usually do is start with the default and increase this value if necessary. We also have a gravity value that in normal situations you wouldn't change, but try experimenting and you will notice that indeed if you change this gravity value, the shape of the ocean waves will also change. Again, most of the time I will just leave this value at its default. We also have a seed value, which is very important. For example, if you want to change the specific shape of these waves, changing the random seed number will allow you to do that. Now, time offset and time scale, I won't change for now. I will show you first some other properties of this ocean spectrum and then come back to these.